Today I'm going to explain maximum candies. This question was from July Lunchtime 2020. I've already made the video in Hindi about this, but I got a request from Shivani Jira for to make it in English, so I'm making this video. You have already read the question, I am assuming. If not, please read it. So I'm gonna explain what the question is and how it's gonna work. So we are assuming we are taking an matrix, okay. And how we are going to fill this is, suppose we are filling it with x is the maximum we can fill in 1, okay, and y is sum between 2. Y is sum between 2, x is this. So we are taking the greedy approach, like we are filling the first one as full. So we'll first fill it with x. Now what we are going to do is, we are going to the maximum we can fill between two adjacent is, the maximum we can fill here is y. So maximum we can fill is y minus x. Okay, you're getting it. If suppose x was 4 and y was 2, y was 6, so what we are going to do is we are fill it 4 and we can fill it 2, because 4 plus 2 is 6, so the condition remains satisfied. Similarly here, because here is 2, so what we are going to fill in this is 4. Why? Because 4 plus 2 is again 6. We are gonna again fill this with x. So this got filled again with x, and this the pattern repeats, and this one becomes y minus x. Okay, getting it? You can see a pattern. Now see the second row. Since x is here, this is also adjacent because this shares a boundary with it. So since x is here, what we are gonna fill is we are gonna fill this with y minus x again. This one will be x, this one will be y minus x, this one will be x. So you can see a pattern. There's a pattern between two. And after this, since y minus x is here, we're going to fill this with x, then y minus x, then again x, then y minus x, and y minus x, x, y minus x, x. You can see the pattern repeats after every two blocks, every two rows. See, okay, so if this one is r1, this one is r2, this one again will be r1 and again will be r2. So what will be the answer? Answer will be r1 plus r2 plus r1 plus r2 dot dot dot, dot m times. This, the total number of rows should be added, should be m. Okay. So what we, so now this was the basic concept, okay, for the common. Now let's see a more case where this thing is odd, n is odd. Okay, so what gonna happen there is, so this one was x x minus y, sorry, y minus x, again x, again y minus x. Now this thing, the new block here which comes is, if it is odd, okay, so this thing will again be x, and again here will be y minus x, x, y minus x, x, and this one will be y minus x. Okay, you're getting this. So this thing will be x. So if whenever the n is odd, now we're gonna add one more, and we are gonna fill this with, we start with x. Why? Because we are taking the greedy approach, and in greedy approach we fill this with full. Like now we are gonna take it as much as possible. Later we'll see what the minimum can we take. So this is what we are gonna do. And if we fill this with y minus x, now when m will be odd, when the number of rows will be odd, that time it's gonna make the problem. Why? Because if 3 is here now, so the see what the sum will be. The sum here is x. Suppose x is 4, x is 6. No, sorry, x is 4 and y is 6. So this will be 4 2 4 2 4. Okay, and so sum will be 12 plus 4 16. Okay, this will be 16, and this one will be 2 4 2 4 2 8 8 8 4. This one will be 14. So suppose when there are only these three rows, so the if we take first x, then the sum will be 16 plus 14 plus 16. But if we start with y minus x, the sum will be 14 plus 16 plus 14. So the here is so this becomes the problem. That's why we start with x and not y minus x. One more point clear. Now let's see what more corner cases are. Suppose there is only one block. N is equal to 1, m is equal to 1. So and x is given 10 and y is given 4. So what we are going to fill here? We are not going to fill 4, we are going to fill 10. Getting it right? 10, because there are no adjacent block, so this condition doesn't get affected. Like the y is applicable when there is an adjacent block. Since there is no adjacent block, we'll fill as much as possible, because there is because y is not there to stop us. There's only one block. Okay, getting it? And there is one more case left. Simple. If x is equal to 10 and y is equal to 5, so if we fill this with 10 to satisfy the condition that sum of 2 doesn't exceed y, so we have to fill this with minus 5, which is never possible. You can never fill negative candies. Okay, so this is not possible. So to satisfy this, what we're gonna do is we're gonna fill this box with 5 and this box with 0. So the so the number of candies will be 5 here, and this is 0, because this is possible. We can fill 0 or we can fill up to x, but the sum should not be greater than 5. So you can see the sum is not getting greater than 5. So these were the corner cases, like this one, this one, where 1 into 1 block is there. And always start with x, not y minus x. And these are all. So come on, let's see the code. So this is the number of test cases. No problem with that. What I have done is I have taken n, m, x, y. These are all the given in the question, and a, b. Instead of n and m, I have taken a and b as input. What I have done is I have given a max to n and minimum to b. So what happens here is, if it is like this, it will transform to like this. So it's not lengthwise, it's breadthwise. So I've done this for my own use. If you want, you can do it other way also, but or like simple as it is given. But for my convenience, I've used this. I've taken again initialize the answer variable for the answer. If 2 into x is less than equal to y, what this line says is, if this is a block and suppose y is 10, x is 2. So if we're gonna fill 2 here, we're gonna fill x, as I told. So if we fill 2 and this one 10, so if we fill y minus x, that will be 8. Is this possible? Because maximum we can fill is 2, x is given 2. So what we are gonna do is, so we are not gonna fill this with 2. Instead of 2, we are just gonna put 2 here again. So 2 and 2. So all the block will be 2. We don't have to calculate anything. So everything we're gonna fill is 2. Getting it? Because 2 plus 2 is 4, which is very less than y, and here also you can see. So for this condition, I've just put the answer as m into n into x. So m is number of row into column into x. So this will be m into n is total number of blocks, and x is candies in one block. Getting it? Now see what happens is, if n is equal to 1 and m is equal to 1, when only one block is there, so answer will be x, because we are gonna fill the max. There is no other block, so the y condition will not be applicable. We cannot apply the y condition only. If m is equal to 1, so if only one row is there, so what we're gonna do is, and check this, if x is greater than y, I explained this here. If x is greater than y, if x is greater, we have to fill the second with minus, so we are ignoring it. So the answer will be y into n by 2. Y, what is this? Let me explain you. This is x and this is y minus x. If we add these two, the sum will be y. Getting it? So, and this pattern repeats throughout the row. Okay. So this will be y into n by 2. And this, as I told you, if one is more block is there for the odd one. Okay. So if the it's odd, we have to add x, as I explained you here. If an odd block is here, so we have to add x here. Okay. So this one was for one row. Answer is equal to answer plus x. That will be 0 plus x. The answer. So the answer, what is the sum of the block, and this will be the last block. N by 2. So it won't take n. If n is like suppose 7, so it will take 3 only. Why n by 2 will become 3, because it is int, not this other one. And now for the normal condition. So if x is greater than y, x is equal to y, we are making it y, because I already told you you cannot put negative. Okay. And see this now. If what we are going to do is, we are going to initialize two rows. Okay. If for r1 is equal to y into n by 2, I already explained. Y is the sum of two blocks and n by 2 is number of pairs of block. If it is even, no problem. If it is odd, we're gonna add an x more candies. Okay, no problem. What we're gonna do is, we're gonna initialize the r2, the row number 2. So y into n by 2, this again becomes the same. The y is total candies in two blocks, and n by 2 is number of pairs of block. Okay. And now you can see, if odd is there, we are not gonna add x, we are gonna add y minus x. Why we are gonna do this? Cause in the second row, we are adding y minus x, not x, because x is here and y minus x should be here. You're getting? See, if you are having a problem, try to draw on your own the matrix, you will get it. So where is the So what I have taken is, I have initialized the r1 number of candies in r1 as kk. I have added a kk to the answer. I'm looping it m times, so the total m number of rows get added. Okay. So what happens now is, answer gets first r1 get added. For answer is equal to r1 gets added. Now it will come here r1. If it is r1, it will become r2. So again looping, then it will become plus r2. Now it is not equal to r1, so it will come in else part, it will become r2. So answer becomes plus r2. Okay, getting it? Then again r1 plus r2. So this will continue on until the condition, until the this condition get dissatisfied, and finally we are printing the answer. So this question was not hard, it was easy, but the problem was the corner cases, the edge cases, where many could have not done. And what was those? First was that when x is greater than y, and when this question, if 2x is less than equal to y, one was this, and when only one block is there. So this was the question. It was really simple, but this corner edge cases was difficult. So I'm also making videos on competitive coding series, like I am doing the data structure and algorithm. With that, interview questions also I am solving on my YouTube channel. A course is going on. If you are interested, please subscribe. I'm uploading videos daily, so I'm sure it will be helpful for you. So thanks for now, and meet